Okay guys, today we're going to be presenting EmotiSense, which is going to be helping neurodivergent individuals to recognize others' emotions during conversations. So who's our target audience for this project? It's going to be neurodivergent individuals throughout the spectrum. So over here on the left we have AJ. This is my brother who is autistic, pretty severely autistic. This system is supposed to help him, as well as your average person who is neurodivergent in a work environment. It's really meant to help all spectrums, and we'll show you how we do that. So how we can help. What we're going to be doing is helping individuals with autism or neurodivergent conditions to recognize others' emotions in real time. So we're going to have systems in place via an iPad and bracelet to recognize these emotions with a computer vision model and then notify them in real time. And the goal here is to help them build interpersonal relationships and effective communication that they otherwise struggle with. So how are we doing this? I just want to give you a heads up view really quick. We're going to have a camera that captures a live video feed of the person that they are talking to. We will run a computer vision model on a mini processor which will output an emotion that that person is feeling, and then we will have a bracelet feedback and feedback on an iPad display. We'll go more in depth with this throughout the presentation. So first, here are some of our requirements. So we have a bracelet feedback time and an iPad feedback time. Essentially, the point of the bracelet is you're getting notified in real time of the other person's emotions. So we want that fast, 150 milliseconds. Keeps it pretty much real time, about as fast as you can react, maybe slightly slower, but still very appropriate for a conversation. The iPad display has a little more information, we'll talk about that, so we expect it to be a little slower. The learning accuracy, most machine learning models, state-of-the-art models nowadays, run at about 79% at the max. So we aim to get about 70 to 75%, just to be realistic. Additionally, this is much above the average, moderately neurodivergent person. Additionally, the most important part is the feedback time, as neurodivergent people they struggle to see other people's emotions in real time. It takes them much longer, on the order of seconds, whereas we're going to be in milliseconds. Our battery life, about an hour. This should last most conversations. Emotion categories 4, we'll talk about this. It's going to be the emotions that are most important and also the ones they struggle with the most. And transmission latency, we mentioned that already. So our solution, we're going to have a webcam. We will have a machine learning model running on the feed from the webcam, and then our output is going to be a wireless connection to the iPad display, and then we're also going to have a wired connection to the bracelet. Optionally, we've also added the ability to do Bluetooth to the bracelet so that you don't have to have it wired or connected to anything. So yeah, and this is an economic and social consideration. We'll mention that. That's why we have 2 forms of feedback. So on the left is the visual feedback with the iPad. We'd consider this a more economic option. If you didn't already know, autistic individuals in school usually get an older generation iPad that they can already use. So allowing them to just integrate our system with that display makes it really simple. Then all they need is a camera. That camera can even be on the iPad. Usually they'll already possess the things they need to run our system. Going over to the right, these are more socially acceptable and helpful for public welfare, aka the bracelet. It's not going to interrupt conversations. You don't have to be looking at an iPad. You'll get haptic feedback on the bracelet. It'll tell you what's going on, and it'll also have lights that'll alert you. So this can ultimately be more inconspicuous and easy for a conversation. This might be more targeted to our neurodivergent person in like a business environment. So yeah, on the software side, we have the camera we spoke about. It's going into our Jetson, which has an OpenCV video feed. We're running a pre-existing facial detection model that is processing at 30 frames per second. Then we are using a ResNet to extract the features of the face. And then from there, I trained a custom emotion detection model. After that, we have a moving average filter and confidence calculations. These are going to go to the website, as well as the bracelet. In the next slide, we'll show you the bracelet. This is our hardware side. Via Bluetooth, we will talk to the bracelet, and it has, most importantly, a motor to give haptic feedback, and then also a NeoPixel, which will be lights to alert you to which emotion. And it'll be different colors based on the emotion. What it looks like, here you can see the start of our system. We have the camera looking at a couple Right here, this isn't part of the system, but we have like what the model is seeing. So it's zooming in on his face, it's giving it a label. And then the two outputs that you'll see during our demo are going to be, right here, it's going to be the bracelet with the NeoPixel and the haptic feedback. You'll see that we've transitioned to have this in a real bracelet. And also the iPad, which is displaying that Capital is angry right now. So the 3 tests that we did is just into server latency testing, classification accuracy, and some user testing that I think are all pretty important for our project. Here are the latency tests, and what you can really get from this is that our latency for everything is usually about 100 milliseconds, much under 100 milliseconds in some cases, and then the maximum order that is really going to ever be is 150 milliseconds, so this is well within our goal that we wanted to reach, and we're very proud of these results. As far as model accuracy, we achieved just above 70%, about 70.5%, which is really good in terms of other models that are on the market right now, especially considering we trained this in-house in a semester. And then, like I said, real-time feedback is pretty quick. So here's, some Capital's angry here, happy, sad. Additionally, our battery life ended up being about 75 minutes, so well above our range of an hour, and it will even last longer in some cases. As far as user testing goes, who we spoke to, I spoke to a high school teacher that was for my brother who's autistic, some verbal autistic individuals, just getting their general views on a project like this, and then a few friends. The feedback we got was that it's very helpful for severely autistic individuals who don't recognize emotions much at all. Unfortunately, the lower accuracy prevents it from being helpful for just your regular neurodivergent person who's less on the spectrum. But still has usefulness for alerting to those emotion changes. Secondly, it can help teach emotion recognitions. Alerting when someone is changing emotions on their face can be very helpful for teaching an autistic individual when that occurs and to just notice it more often, which can make them better in normal conversation. So additionally, the bracelet can easily become a more discreet, user-friendly option, and it's a little hard to mimic the face that you want the model to catch on to, just because it's catching our natural emotions, not necessarily what you expect angry or sad to look like. So some of the trade-offs that we had, we trained a model with a little bit slightly higher accuracy, but you can see by this graph, as you increase the accuracy, the model gets more complex and it ends up having a much higher latency. We wanted to stick around the 100 millisecond mark, so we ended up choosing the model with 70.5% accuracy. And then additionally, as far as emotion categories, a lot of these really state-of-the-art models, they start off with a bunch of categories and end up going lower just to increase their accuracy. And we end up doing the same. We started with 6 emotions, we ended up going down to 4 to increase the accuracy and reliability. Some of our takeaways, facial motion recognitions is a pretty hard technical challenge. Like I said, the highest models are about 79%, so we're not fully there. But as this technology evolves, our project will get more and more useful. Seamless integration takes a lot of time. Luckily, we were able to finish. Parents and teachers of autistic individuals seemed pretty interested, especially in that concept of reinforcement learning and notifying when an emotion changes. And then finally, there's growing recognition of neurodivergent in work environments, which this project can also help those people, especially with minute subtlety with something like the bracelet. And that's going to be the end of our presentation. We'll bring you to the demo in the lab now. Okay, guys, so we wanted to give you a POV of our project. As you can see, this is what the computer sees right here, detecting Mason in a... Mason, can you make a neutral face for us? Boom, there we go. Okay, Mason, try a happy face for us. So as you can see, if I'm talking to Mason, it shows he's happy right now. I have my bracelet on, shines green, showing he's happy. Try an angry face for us. There we go. So we have on display that he's angry. It shows a confidence of 100 and the time elapsed of how long he's been that way. Our bracelet also shows red now, and we get a notification via haptic that he is angry. Mason, why don't you try sad for us? And as you can see, we have a pretty confident sad. The bracelet shows blue, and that's essentially what would happen. And it would change throughout. You have the conversation. You can go back and forth. Mason, if you want to cycle some emotions, we'll see if we can make that work. There we go. So as you can see, it's pretty responsive, pretty fast, and we're pretty happy with it. So I hope you get the chance to use it. Thanks, guys.